All right, so this is our first office hour for the Phase 4 project. I just wanted to start by saying that you should have received an email. If not today, look out for it this week. You should get an email inviting you to Path Right, which is basically where your career coaching materials, as well as some post-work materials, will be posted. So do look out for that and do sign up. I believe you can sign in with your Flatiron School portal. So if you get an email to that, that is basically where all your post-grad curriculum is going to be. There are like a few more topics that are, recommended for y'all to look into post this program. So that material will be on there, as well as career coaching curriculum. So if you don't get that email asking you to sign up for Path Right, and I'll put it in the Slack channel later as well, let me know by the end of the week. But in the back end, you should all receive it, I think today or tomorrow latest. So just wanted to let you all know that that is starting. And then your career coaches will be reaching out to you by next week. So look out for that email as well. I would say if you have multiple emails, it will be the one that is connected to your Flatiron School account. So just look out for that. And if you have any questions, or if you don't hear back from your career coach, I will be reminding you all, if you don't hear your career coach by the 8th of February, just let me know and I will find out what's going on there. So that's on the career coaching front. I know a lot of you are excited to get started with that stuff. So yeah. So I think that's the only announcement that I have. Just watch out for those emails. Those are going to be very important. And yeah, let's get into these questions. Thank you to whoever organized this. Makes my life easier as well. But yeah, let's start with recommendation systems. So first question that we've got here, this person created a baseline model with SVD that had no hyperparameters. On the one hand, you can also check to see what the default parameters are. It's on the documentation. With grid search with several hyperparameters, RMSE results, as well as average test RMSE from the cross-validation all perform worse than the vanilla model. Upon tuning hyperparameters, nothing really makes the vanilla model better. Intuition as to why this is happening and how can you adjust the model to yield better results. So I'm going to assume that the baseline model was ran just with a chain test split without grid search. So one reason why it is possible that your average RMSE when you're doing grid search will go down is just because there is a little bit of not overfitting, but it is going to be fit to your train set. So therefore, the same hyperparameters, while you're doing grid search, when you're fitting the same parameters across your different folds of your data, it is not unlikely for your RMSE to not do much better because your RMSE values are going to be averaged over the different folds of your data. I will say though, with recommendation systems, it's a pro and a con, but the errors in your data are not as detrimental to your real life scenario compared to something like, a classification or a regression model. Just because you're trying to make recommendations and because, it's so subjective, the error values are really just telling you how well your model is fitting the data. But yeah, it doesn't necessarily mean that you'll have bad recommendations just because of the subjective nature of recommending things. In terms of how can you adjust, so that is my intuition as to why that is happening. How can you adjust the SVD tuned model to yield better results? I will say one thing that you can do to just as a step to check, and I'm also going to type, why don't I just type this down, type this out as I'm saying this so I don't forget. But one good thing to check is the sparsity of your data. Because, the whole idea of SVD is you're filling in a matrix, the more values that you have, the easier it is to, fit your data. If you don't have too many values in your utility matrix, it's going to be very hard to fit your data. So as one step, check the sparsity of your utility matrix. And that is found by taking the number of users multiplied by the number of items. Oh yeah, and then you have to divide it. You want to divide the number of ratings divided by the number of users times the number of items. SVD's performance goes down if you have a sparsity of over 95%. So if this number is lower than 0.05, nothing to do with the p-value 0.05. This is just like a standard benchmark. If your sparsity is less than 0.05, SVD's performance tends to go down. Not to say that you can't use SVD, is just after that, that means you only have like 5% of your data points in your utility matrix. It just doesn't really have much to go off of. So yeah, that's one more thing. And then also what I mentioned before, grid search is averaging your test values and hyperparameters might overfit to a certain fold. So average test RMSE could be lower as a result. Any follow-up to this? All right. So next up, what's an example of a combined content-based and collaborative filtering model that would be used in this project? How exactly would you recommend content-based models in this context? What I would recommend would be using LightFM. They basically combine SVD with a content-based system, and kind of like I personally haven't really looked into exactly how they're balancing both the content-based and the collaborative filtering side, but it is something along the lines of you're doing the SVD and then you're just reweighting the recommendations based on item similarity. So basically, if for a specific user, if for some reason, for example, there's a lot of popularity bias and you're just getting recommended like the ones that everyone has rated 5. Based on the content information that you've given, your model will be able to see, all right, this user has liked whatever movies, for example, and then just reweight the recommendations based on how similar the movies are. So the predictions will get reweighted that way. So LightFM has all of this built in. It's a little bit annoying because you would have to make different data objects. So you would have like your utility matrix. You would also have a specific feature matrix, I think. And yeah, I think that is it, like the interactions. I have linked up here, and there are a bunch of others. If you go into LightFM, they have a lot of good walkthroughs. So this is just one example of how you build all these data objects. And if you go into examples, there are a lot of different objects, a lot of different examples. Movie Lens is the data set that was provided for the project. So, I mean, if you want, you can take a look at this, but I believe that this only uses the collaborative filtering portion. But yeah, feel free to explore these. These examples are written by the people who wrote LightFM. So it is how they these examples are how they intended the library to be used.
So that would show you then how to build like a feature matrix where you have your separate features that it's going to take into account when you're reweighting items based on similar items.
That's right. I believe the one that I have here does the feature matrix. So this is the interaction matrix, which is the utility matrix, and the feature matrix, I hope it's here. So this is ID mapping, feature matrix. I guess maybe it's not here. All right. I know that they have one that definitely is, because when I was doing a project with LightFM, this is what I used as well. Okay. So yeah, just explore around. I'm pretty sure. Oh, build item features. There we go. That's the one. Building item features. That would be the content base. So if you want to take the movie data, for example, you can incorporate that into your matrix, into your model.
Okay.
With this.
Cool. And then I don't understand what is the output of LightFM going to be? What is it going to return us back? And then how you jump from that to applying like a classification model or something.
Right. Okay. So the output of LightFM is going to be the same output as Surprise, which is literally you give it your user ID, item ID, and it'll give you a predicted rating. And so you can actually use very, very similar code to like for a particular user, get all the predicted ratings for items that they haven't consumed or rated before, and then you can just sort them and recommend. How you would use it for a classification model, I guess it depends. Like you don't actually have to do a classification model with recommendation systems.
Okay.
What could happen is you could use the output of this to use as training data for some classification model. Like for example, if you wanted to recommend something for, I don't know, if you wanted to recommend, I don't know, whether someone will like a movie or not, but then again, you could just use the predicted ratings for that. So
right. So the predicted, it's going to give us a prediction depending on the user that you would put in. So then your test set, I assume, or like your unseen data, it'll just give you all those predictions for those users. And then based on like certain movies, and then you would be able to pick like the top 5 per user or something. Yep. And say like these are your recommendations by creating like a prediction function or something.
Yes, like that's right. Yeah. Okay. Yeah. So I will say for recommendation system, I mean, it is not a necessity for this project, but it is good to have some sort of function that's able to generate predictions so that you can actually use your system.
So you wouldn't
it's not necessary, but
have to build like another machine learning algorithm on like a classification model or anything. It'll just already give you the predictions, and then you can. Yeah. That's the model, I guess.
Yep, that's right.
Okay, cool. Thank you.
You're welcome. Let's see. So LightFM is built in. I do recommend that one. And then let me just put this here. Hold on. And this is linked to building dataset objects. And let me link that here. Alternatively, and this will be a little bit harder. Let me just put this hyperlink here. Alternatively, you can manually do it. So after alternatively, you can build SVD with Surprise. Alternatively, there we go. Build SVD with Surprise. And then you can actually reweight it on your own. And reweight your predicted ratings based on a user's rated movies and their similarity to others. That one does take some creativity. There is no like standard way of, all right, you're gonna multiply the predicted rating by the similarity value between movies that the user has already rated versus everything else. That is one way to do it, but there is no like set way to do it. It's really up to you to get creative. I will say when there was one product that I did a hybrid recommendation system for, and the way I reweighted it, it was because I actually built one to recommend board games. And there were certain things I wanted to weight higher than others. So I did like a nearest neighbors with like custom weightings. There were a lot of dummy variables. So that, yeah, I mean, it's really up to you how you want to weight it. It's there's no standard way to do it. So yeah, I do recommend using LightFM just because it is a good library to get familiar with, honestly. I know that in industries, like people actually use this in the back end of their recommendation engines. So that's just a cool thing to know how to use.
Sorry, yeah, before, For a baseline model, can you do, so if you were using LightFM, could you do just like a, like what is it, like the KNN baseline model as your baseline, and then
Yeah.
use LightFM to have like a more robust model, I guess?
Yeah, absolutely. For any of these projects, the baseline is really up to you to decide what your baseline is. As long as
Okay,
the metrics that are output are similar,
right.
um,
Okay,
yeah, it really doesn't matter what exactly your baseline is.
cool. Oh,
Any other recommendation systems questions before we move on? All right. So next we have some time series questions. So in the lessons, we use log transforms, rolling means, decomposition, and differencing to get our data to be stationary. That's true. But then using ARIMA or Saramax models, particularly with grid search, they'll do the optimal differencing. So do we not need to make our data stationary before modeling, aside from just looking at it for EDA? Yeah, the models will do it automatically for you, especially if your model has like an integrated component. As long as the model has an I in it, it does the differencing for you. So you don't have to do the differencing as a pre-processing step. So any model with a D with a differencing component or letter I will do the differencing automatically for you. So you don't have to do that as pre-processing. That in your pre-processing steps. So yeah, aside from just looking at it for EDA, I will say that to even build your grid search, um, you should do your EDA and the Dickey-Fuller test, just so you know when your grid search is giving you results, you'll be able to validate or verify that that makes sense as like a differencing value. Um, Sometimes it just so happens that a model can just like spuriously fit well, but it's not. It fits well to your training data, but maybe a differencing component is required to forecast later time periods. So you should still take into account how much differencing is required for your data to be stationary. So, but you still should find out in your EDA to verify the D value grid search gives you. All right, any follow-up questions to this? Cool. So could you explain the different uses between get predictions and get forecasts in Ceramac? So this part is a little bit confusing. I guess I never really specified what the difference was between get predictions and get forecasts. So the main difference is what data has been fit on. So get predictions is for data that your model was fit on. So basically, if you want to get predictions on your train set, that's where get predictions comes from. Now, get forecasts. This gets a little bit complicated because, especially when you start having like moving average terms, because moving average terms, you have to account for like the error in your previous predictions. So when you're making forecasts, because you can make forecasts for like however many days in the future you want, of course, because you don't have, let's say I'm making a prediction for tomorrow. I don't know what tomorrow's price is going to be yet, but I also want to make predictions for the next 5 days. I'm not able to know what the error tomorrow or the day after is going to be. So the future predictions are unable to take into account, it's going to guess what errors are, but it's not going to be able to make meaningful forecasts, especially if you have like a moving average term, like an error that is involved. So what get forecast tries to do is it tries to estimate the errors. So forecast is anything that is anything that comes after the data that you've trained your model on. So get forecasts is for data that your model was not fit on. because you're trying to forecast without any data to validate. And it is the same between Ceramax and basically, yeah, for any of the stats models, time series models, forecasting and predicting mean these two different things. Any follow-up to this?
Yeah, could you explain then what dynamic forecasting is again?
So with dynamic forecasting, I believe they also give you a variable. Let me just double check. Let's see, Ceramax dynamic forecast. Here, I wonder if it's in this link. Okay, so dynamic forecast, and not just for so you get to give it integer offset to, okay. So if you want dynamic forecasting, basically if you so let's say I train my model on days 1 through 20. If you do a dot predict on days 1 through 20, it's going to take into account all of the errors throughout this time, and it's going to fit the model that way. So dynamic forecasting, I believe what it does is it sort of adjusts the model, or it acts like, let's say you do dynamic forecasting to start at like day 15. Now, if you start at day 15, dynamic forecasting will not take into account the errors in 15, 16, 17, 18. Is just going to forecast as if you only trained your model on 15. Does that make sense? So forecasting is different from predicting, because predicting, your model has been fit on it. Forecasting and dynamic forecasting, dynamic just means that you change like what date you start making the forecasts. So what date you like stop considering the like actual values that were given. So yeah, does that help?
It's still a little unclear, but I'll read up on it. Thanks.
Yeah, I'll look for something that can explain it better than I can. So dynamic forecasting, and I'll send it out and I'll put it on this guideline doc as well when I find something. I'm sure there's a better resource than what I can come up with right now. All right, so I will get back to you all on that. Any other follow-up questions on this, or perhaps like using any of the time series models? All right, well, the last question that we have here, and again, please add questions if you like. What actionable information would running a clustering model on the zip codes provide? So this was just more of like a suggestion of how you could go about this project, because you're given zip code real estate information for, I think, over 200 different zip codes. The idea of clustering zip codes just means that you wouldn't have to run your clustering, wouldn't have to run a time series model separately on each zip code. So if you're doing a clustering model on the zip codes, you'd be able to basically group zip codes together based on how similar their like trends are. So in terms of what actionable information, you'd be able to group zip codes together based on, I guess, their trends over the last, I forget how many years this data set is, however many years. Oh, don't forget to scale your data if you want to do clustering. To scale your data if you want to do this clustering. And scaling, again, it does depend on how you have your data frame set up, because I know it is like zip codes and also dates. So if you have, it's important to scale your data properly. I would say that you definitely have room to play around with this, but off the top of my head, the way I would scale my data is just change everything to a percentage change. So for example, let me just put this here. Scaling, I would start at like a 0. So for example, like the first data I have should all start at 0. 0 for each zip code, and scale values to become percentage change over each month. And so that kind of gets rid of the actual price values, and you're more trying to cluster your data points based on the movement of, you know, your housing prices. This is not the only way to do it. This is my suggestion. It's just suggested, not the only way. So this, yeah, scaling it this way would just, you know, group your, for example, like if there are a bunch of zip codes that are constantly going up in price, they would be clustered together. If there are ones that go up and then down, those will be clustered together. Again, it also depends on how many clusters you want to create, but it would hopefully make your modeling process easier. And this is if you want to use all 200 over zip code. You don't have to, for sure. But yeah, that is the kind of actionable information that you would use. Just so you don't have to run like 250 different time series models, you can just do like maybe 5 and have each one like generalize. So yeah, that is my suggestion for that. Again, for the time series project, you don't have to answer the question that they have posed. Feel free to come up with your own question if you feel like that question is a lot of, I don't know, extra work or something. Yeah, as of right now, any other questions that I can help answer?
I was just going to add to that one. So when you run the clustering, then and you come up with however many clusters you decide you want, then you have to run graphs or visualize to sort of see what the trends are, or how do you find out what the differences are between the clusters?
Yeah, for sure. With any clustering, you would want to do some post-clustering EDA just because it is not immediately obvious how the clustering is done. So after running your clustering model, you definitely want to plot your data. Definitely want to plot your data. Honestly, I feel like if you were to just plot like all the lines in one graph just to see like the overall trend, that will be fine. You can also take like a random subset to see what they look like. So yeah, to see what each cluster's trend is. So yeah, and then you can basically argue that, you know, you only need 5 different time series models for all of the zip codes that were provided.
Is the clustering really just looking at trend, or would it also be looking at like variance or comparing that too?
Yeah, you're right. It will also take into account variance. Clustering, honestly, I made that suggestion just because it's the easiest, like the most direct way that you could potentially group the zip codes together.
I'm not sure I'm going to do it, but I so don't spend too much time on it, but I was just curious how it would work.
Yeah, I mean, the clustering, what it'll do is it'll look at, you know, it'll basically see like, all right, it'll sort of treat each time point as a column, if that makes sense. And then it's just doing sort of like a nearest neighbors on that. So that's why I suggest doing like some sort of like percentage change. You could also do absolute change, just so that, you know, if in a certain month all the prices are going up, or maybe like half the prices go up, half the prices go down, those would obviously be like the 2 groups in when you run your clustering model. Again, yes, variance will also be taken into account, but likely it would group like, for example, if in 1 month half of the houses go up by like 20% versus 10%, those would probably end up being 2 different clusters. Because it's really just, well, in the way that I suggest this suggestion here, I don't suggest that, I mean, you all don't have to do this if you don't want to, for sure. But yeah, and the way that this is set up, it would also take into account like the variance, but also it would take each, it would take each month to be a different row. Sorry, a month to be a different column. So based on that, like not so much overall variance, but basically the variance together, if that makes sense, during the same time period. I don't know if that like just ended up confusing more people, but yes.
Thank you.
You're welcome. You're welcome. Anything else right now?
So sticking with the clustering theme, if I'm doing NLP, the input into the clustering would be my count vectorized or TF-IDF, right?
That's correct. Yes.
Okay. And then how does LDA differ? Is
So yes,
is LDA a type of word embedding?
LDA is not a type of word embedding. LDA, and let me actually just make a section for that, just so we have it here. So a section for natural language processing. This auto like text is super, super good. All right, so natural language processing, what is LDA? And how does it differ from regular clustering? Differ from regular clustering. So LDA is a soft clustering model. So what soft clustering means that, so with k-means, basically every data point was only in one cluster. With LDA, it's more probabilistic. They'll actually give you like the probabilities of a single row of text belonging in each cluster. So therefore, you get like probabilities of each row belonging to each cluster. And then versus hard clustering, each row solely belongs to one cluster. So yeah, LDA is a soft clustering model, which is different from hard clustering. The other thing is that LDA specifically will pick out context. So LDA clusters not based on like your word count, not based on like your TF-IDF. It actually does it based on the context of your words. So LDA does have that built in of your words. So that's why LDA is known as a topic modeling. LDA is known as topic modeling because your clusters will be topics, which is slightly different from if you were to run k-means, because k-means will do it just based on word count. So I can type that down. K-means or even HAC will do this based on probably your word counts or TF-IDF. Likely the ones that have, certain words more will be grouped together. So based on that, you might still get topics, but it is less context driven. So this is less context driven. Oh, not will do this based if. So you can do k-means or HAC on word counts, which will make it less context driven, but you can also do k-means and HAC on word embeddings. So that's how you can include context in your clustering without LDA. I will say LDA mathematically is a little bit more complicated. I personally haven't really looked into how LDA is specifically done. But LDA is more straightforward just because you have that really nice output. And even if you don't have that nice like interactive output, the output still is like the probabilities of words and the salient words in each topic cluster. So I would, because of this, recommend doing LDA over the others. But I mean, as an EDA tool, you can really do either.
Okay, thanks. I think you mentioned when we went over this in the study group that you had some good references or resources, like a walkthrough of LDA.
Oh, yes.
I think
Okay.
we
Yeah,
can
let
get
me write
those.
that down as well. Yeah. Last
Thank-
week I was pretty bad at writing stuff down, so I will get that for you. Yes, I will get you an LDA walkthrough after this as well. Okay. Any other questions at this moment?
Mm, Yes, I have a question about, I want to use new packages in my notebook,
Mhm.
but I already imported them. I don't know how to use them without restarting my kernel.
So if you want to use new packages, you've already imported them, so they work or they aren't working right now.
Yes, actually, I imported Matplotlib, but its version is 3.1.1. But I need
Oh,
a
okay.
higher version, so I updated it, and I don't know how to use the newer one.
Okay, yeah, and I know it's because you don't want to rerun all of your neural networks. One thing you can do, honestly, that because if you want your Jupyter notebook to use a new version, you unfortunately have to like restart your kernel in some form. One thing to get around it is you can actually pickle or save your your grid search output, your Keras output, for example, just so like you don't have to rerun everything again. You'll still have those models stored. In terms of, yeah, unfortunately, in updating packages, that's what you'll have to do. There are ways to update your package just within your Jupyter notebook and have it automatically use it. But I believe because you're in the learn environment, that becomes harder. And if you want to get out of your learn environment, you would have to restart your kernel anyways. So unfortunately, no direct way to go about this. Unless, no, I don't think there is any way to go about this, unfortunately, without restarting your kernel.
Okay, and I find a library importlib, but I think it only works for scripts, right? It doesn't work for other libraries.
Import lib. Any library should work just fine in scripts versus Jupyter Notebook. If they're asking for like a command line, if you need to use like a command line to like get it to work, in your Jupyter Notebook, as long as you start your line with an exclamation point, it will treat it like a command line tool, like a command line command, if that makes sense. Yeah. If you want to like send me what it is you're trying to do, I can on Slack, I can take a look at it as well.
Okay, sure.
Anything else that people are actually, before I take more questions, I did also want to talk really quickly about GitHub. I've been getting a lot of GitHub questions over the past day and a half. So with GitHub, I know a little bit more than half of you are working in groups, some of you even in groups of 3, so GitHub becomes very important. Things I want you to remember, actually, let me just do this, GitHub. So things to remember. Here we go. First, you unfortunately cannot collaborate with notebooks. So Jupyter notebooks are not good for collaboration. And the reason for that is, I don't know if anyone has ever taken a look at like a raw Jupyter notebook. I think I mentioned this like in phase 1, but not important to remember this. But if you ever looked at like a raw Jupyter notebook, it's actually a JSON file. And the reason why Jupyter notebooks are very, very hard to collaborate on, you can see as part of this JSON file, let's just see, I think these are empty, but right now you can see execution count. So basically this is, when you run a cell, the number that pops up. So basically if you run a cell, the file already changes. So because every time you're running a cell, you edit a markdown. I think markdown is like in this format. So because of that, Jupyter notebooks, you'll almost always get merge conflicts that become very, very difficult to resolve. And resolving a merge conflict in a Jupyter notebook, you would actually have to go into the JSON file and edit the different things. I've done it like once before, once successfully. I've attempted multiple times, but it is very, very hard to edit because you would still have to make sure, all the dictionary like things are open and closed at the same time, and it's nested as well. So because of that, Jupyter notebooks unfortunately don't collaborate very well. So likely you will be working off of separate Jupyter notebooks and then combining your code at the end, or just send each other your code snippets through Slack or something. So that is very unfortunate. If you're taking your code and you're putting it in a Python file though, Python files, you don't have this problem because Python files, let's just see if I have any like Python files here. I don't think so. I think maybe in this one. No, never mind. Python files you can just open. You don't have like all that JSON formatting to worry about. So collaborating on Jupyter notebooks is hard. So yeah, you would have to work separately. They're really JSON files. So every cell run changes the file. And then therefore, lots of merge conflicts. So therefore, you also want to work on separate notebooks. Also, another thing that people have been running into is large files. So Jupyter Notebook has, it's not Jupyter Notebook, GitHub has a file upload limit. I believe it's like, I forget if the limit is per file or per repo. I honestly don't remember. But if you have large files, it's just better to not have it upload onto GitHub. So to do this, one, you have to make sure that your file name or data folder name is in the gitignore. And when you can edit the gitignore locally as well as you can also edit it on the GitHub page itself. So yeah, if you run into problems with that, you would get an error when you try and do git push. It'll let you add, it'll let you commit, it just won't let you git push. So Git will let you add and commit, but not push. So the way you have to get around this, if you do run into this error, you actually have to uncommit and unadd. So let me just, I do have the lines of code saved somewhere. So let me just put this here. If you do run into this, rule 1 is don't keep trying to commit and push. The pieces of code, and let me just pull that up on my end real quick. This is one of the ones that I keep in my notes because it happens all the time. So first, you would have to undo your last commit. And that is git reset. Ooh, interesting text color. All right, so git reset soft head 1. And what that is it rolls back one commit. And then you also have to unstage either the file or everything. So you would have to unstage your file or your large files, and that is through this code, git restore staged file, or you want to do git reset to unstage all. And then at this point, make sure you edit your gitignore and try again. So if any of you run into big issues with like large files getting pushed to GitHub accidentally, these will be the steps that you will have to go through. If you found that you've done like a lot of adds and commits, you would just have to reset. You just would just have to do this step over and over again until you unstage the large file. One thing I do recommend do git status with every step until you see the large files being untracked. So those are GitHub things to remember. Yeah. Has anyone else been like dealing with GitHub issues that I can help with? I mean, if there is, I'm sure you'll have already let me know. So yeah. Any other questions at this point? Can be
Sorry to
about
jump
anything.
Sorry to
good.
jump around. I have a question about back to recommendation systems. So you
Yeah.
said that if you check the sparsity of your matrix, you do number of ratings divided by number of users times number of items. So if you get a super small number, but you still have, like if you get a super strong number and your RMSE isn't super high, what does that mean, first of all? And second of all, if we look at the if we look and we find that our matrix is very sparse, how will that affect other models like KNN? Because if they're looking for nearest neighbors and then the matrix is really sparse, then how does, like, basically mine is really sparse, and I'm wondering how that affects my models beyond SVD.
Yeah. So if it's very sparse, I mean, the first thing you see is that your model's RMSE doesn't usually get very high. Also, with like if they're trying to do like neighborhood methods, that any like memory method, like the KNN basic model, they're only going to compute similarity across other items that like users have, other items that the user has rated. If not, like you're not able to even get these similarity values. So you might end up with quite skewed recommendations. One thing that you could do is you could drop any users or any items that don't have like a certain number of reviews. So that will help, reduce the dimensions of your utility matrix, and therefore your sparsity should go up. Drop any user or item with fewer than X ratings to increase sparsity. I forget if there was another question as part of your question, Adina.
Well, I was also just curious, like you're saying that if your sparsity is less than 0.05, then SVD's performance tends to go down, meaning it gets worse. So now you're aiming to have a higher, like a more sparse matrix.
Okay.
Yeah.
Wait. Oh, if your number is, if your sparsity is lower than, if it's very, so this just, okay, I've got like the double negative going on here. So if sparsity, all right. So this number would be like the inverse of sparsity, right? So it would just be 1 minus. So if your matrix is, I'm going to just reword this. If your utility matrix is more than 95% sparse, SVD's performance tends to go down. Hopefully
that makes more sense.
Clear.
Yeah.
Okay. So basically, 95% sparse just means that in your utility matrix, you have you have less than 5% of the values actually filled in. And why your performance will go down is because when your model is trying to do the alternating least squares gradient descent, it has less values to match up with. And so all of those blanks are just going to be, I don't know, there's nothing to anchor other values to. So that is usually why the performance goes down.
Got it. Okay. That makes sense.
All good. All good. Anything else at this point? I'm trying to think if there's anything that I came across while working on these projects too. Remember that baseline models can be anything that you decide. It's really up to you to decide what your baseline is. You can have multiple baselines too. If you want to just like, segment your project that way, you can definitely do that. But yeah, I mean, we're also all like pretty close to an hour of time. Any final questions before we close out? Of course, my Slack is always open for questions. I will get those additional resources in here as well. Cool. Well, if there are no further questions, going once.
Yes, I have another question.
Let's hear it.
If it is possible, can you send something that I can read to learn more about the kernels in convolutional 2Ds?
Ooh, okay. Let me just put that here as well so I remember. So for convolutional kernels, actually, let me just put this under here, under image classification, just so it's organized. And talk about convolutional kernels. Yeah, I'll look for something. I think there are a couple. They might be quite dense because I know that they're probably research papers, but let me see what I find and I can send it over.
Thank you.
You're welcome. Any final questions now? Going once, going twice. All right then, sounds good. Again, my Slack is always open for questions. I've been getting some really good questions. I feel like there is, I think as I mentioned, I think I mentioned this in my stand-up, but questioning the process of doing your data science project. Like for example, when do I do like my chain test switch versus grid search, and how does that, drive my modeling process forward? The fact that I'm getting quite a few questions on those things, I really, really appreciate, because for the purpose of, this being a learning environment, questioning those processes is ultimately more important than, your final product. So yeah, keep sending over questions to me on Slack. I'm having a really awesome time just answering those. And if there's nothing else for right now, I believe that Stephen wants to do a happy hour on Thursday. So look out for that Slack message. And I will see you all back here tomorrow. Keep the questions coming. Yeah, and those will drive our next few sessions. All right, have a good rest of your day, everybody. Bye.
I thank you.